Hello. Today we're going to talk about truth tables. Truth tables are absolutely the most challenging aspect of this course. Let's begin by reviewing the 4 basic truth tables. The first one is the not truth table with this little curly thing and then a P. We call this not P. The not truth table. It is true if P is not true, no matter what Q is. Now normally when we set up a truth table, we set it up this way. We start with P and we put true, true, false, false. Then Q, true, false, true, false. Notice now if we just look at this portion, we have covered all 4 possibilities. We have what happens when P is true and Q is true, what happens when P is true and Q is false, what happens when P is false and Q is true, and what happens when P is false and Q is also false. So this is why we begin it this way. Note that to figure out not P, we're only going to look at the P column. We're going to ignore the Q column altogether. So if P is true, then not Q is the other one, false. If P is true, then not P is false. If P is false, then not P is true. And if P is false, then not P is true. Alright, let's look at the second of the 4 basic truth tables. This is the P and Q. That little hat looking thing is read and. So this is read P and Q. This is the and truth table. It is true if both P and Q are both true. In other words, this is true if P and Q are both true. Not just P, not just Q, has to be both. Here we've set up our basic truth table the same way we always do. Note that when P is true and Q is true, then P and Q is true. But when P is true and Q is false, P and Q is false, because one is not true. Since Q is false, it is not true that P and Q are both true. Similarly, when P is false and Q is true, then P and Q is false. Of course, if P is false and Q is false, then P and Q is false. Let's look at the OR truth table. P or Q. This V looking thing is read OR. So this is P or Q. This is true if P or Q or both are true. So if P is true and Q is true, then P or Q is true. If P is true and Q is false, then P or Q is true, since one of the two, namely P, is true. That's good enough. If P is false and Q is true, again, P or Q is true, since Q is true. Note that when P is false and Q is false, then P or Q is false. Now let's look at the tricky one. P, and then this little arrow thing, Q. This is read if P, then Q. This is called the if-then truth table, and it's the trickiest one. Let's go over the basics. If P is true, then P implies Q is true if Q is also true. However, if P is false, P implies Q is true no matter what Q is. Let's look at the table. If P is Q and Q is true, then if P then Q is true, since P is true, but note that that implies Q is also true. If P is true and Q is false, then P implies Q is false, since P is true, but note that this does not imply that Q is true. What happens when P is false? I know it is a little confusing, but with the if-then statements, if the if doesn't hold, we just don't care what the then is. So false implies true is true, and false implies false is true. This is because the if part wasn't in place, so the then part doesn't have to hold. If it does, okay. If it doesn't, okay. So when P is false and Q is true, P implies Q is true. And when P is false and Q is false, then P implies Q is also true. Note that there is an example of this same situation on page 125 of your textbook, and the last row, the bottom pink T. However, the notation in the textbook is much more confusing than the notation used here. I recommend you avoid using the book's notation and instead stick with the notation we're using here in the truth tables demo.